Hey everyone, Charlie here from the Atomic Age, back at you with another nuclear news. Today's main topic is we're going to talk about Fukushima water release. This started 2 or 3 weeks ago. Before we get to Fukushima, first we will start with this piece from World Nuclear News. Germany has shut down its last nuclear reactors. It's happened back in April. It's kind of tied in with Fukushima. The German process to shut down their last nuclear reactors was kind of in the wake of Fukushima happening. German reactors have had a very great track record of safety, great operational record. Of course, prevented a lot of carbon emissions into the atmosphere because nuclear energy does not emit carbon. All right, so let's now move on to the main story of today's news video, and that is Japan has started releasing treated radioactive water from Fukushima into the ocean. Several people have asked me about this, and in short, there's nothing to worry about. This is something that nuclear reactors do all the time, is release controlled amounts of tritium. It's a byproduct of some of the materials in the reactor. So what is tritium? Tritium is an isotope of hydrogen. So this is all just to say that tritium is just a different form of hydrogen. Yes, that common hydrogen that appears in your water is H2O. But what makes tritium a special form of hydrogen? If we look at an atom of hydrogen, so that's the smallest chunk of hydrogen you can have possible, normal hydrogen is 1 proton in its nucleus. Tritium is the same as this, except that it has 2 neutrons in the nucleus with the protons. So you get 3 particles in the nucleus. That's where you get the tri from. So there you go, you get tritium. So because tritium is a type of hydrogen, it can bind with oxygen to make tritiated water. Now this is why the tritium cannot be filtered out of the Fukushima waters, because it is chemically bound to the water. It's literally part of the water. So the classic formula for water is H2O, 2 hydrogen atoms, 1 oxygen atom. With tritiated water, it's HTO, hydrogen, tritium, oxygen. One of these stable hydrogen atoms in water has been replaced with an unstable tritium atom. Now, tritium is a radioactive isotope. It is unstable. Radioactivity, unstable, all this means is that the tritium wants to get to a more stable state, and it does that by releasing radiation. So according to the United States Nuclear Regulatory Commission, tritium is one of the least dangerous radioactive materials, and this is because the radiation it emits is rather weak, and it leaves your body rather quickly, because tritium is most often in the form of tritiated water. So there's the nuclear half-life. Bear with me here for a second. There's the nuclear half-life, where it takes 12.3 years for half of the tritium to decay to a stable form. But there's also something called biological half-life, and this is how long it takes for half of these materials to leave your body. So for the case of tritiated water, it's about 10 days for half of it to leave your body. So that's really what makes it not so dangerous, is that it leaves your body so quickly, because it's water. It leaves via urination. Just as an aside, if tritium is bound into something like an oil or some kind of fat that also has hydrogen atoms, it can stick in your body for much longer. Okay, so now they're releasing this tritiated water into the ocean. Are they just going to dump it all out at once? No, it's going to be diluted concentration over many years. The concentration of the release is about 1,200 or even 1,500 becquerel per liter. 1 becquerel means that 1 radioactive atom is decaying or becoming stable and giving off radiation per second. So 1,200 or 1,500 becquerel sounds like a lot, but it's really not. It's really a rather small amount. Where I work in shipping nuclear material, it's very common to work with amounts that are more in the range of gigabecquerel, so 1 billion becquerel, or terabecquerel, so 1 trillion becquerel. 1,200 to 1,500 becquerel is rather low. To give you another sense of scale, a fuel pellet for a nuclear reactor, which might be as big as like the head of this AA battery, has about 1 million becquerel of uranium atoms in it. So that's just to give you another sense of scale here. In addition, in your body right now, there are 5,000 becquerel of potassium-40, which is a radioactive isotope you get from eating bananas, for example. Not to say that the risk from tritium and potassium-40 are analogous or similar. Just to give you a sense, another sense of what kind of quantities of radioactivity we're dealing with here. Try and give you some context for these numbers, because people can throw these numbers around and it can get very confusing very quickly. All right, now let's get back into talking about some hard numbers about tritium exposure. Set the stage a little bit here. Nuclear power plants routinely release safe amounts of tritium. Sometimes the nuclear power plants have tritium release uncontrollably, so a spill, and that can leach into like well water, groundwater, and people can drink this. I'm gonna read from my notes here just to make sure I get it right. So, per the United States Nuclear Regulatory Commission, if someone were to drink well water contaminated with tritiated water at a concentration of 60 becquerel per liter, so Fukushima is around 1200 or 1500, that neighborhood. If someone were to drink that water, 60 becquerel per liter for a year straight, they would get a dose of about 0.3 millirem, which is 3 microsievert. Okay, so more confusing radiation numbers. Let's look at some comparisons. So this is 2,000 to 5,000 times less than a full body CT scan, 1,000 times lower than your natural radiation exposure to background radiation per year, 50 times lower than your annual dose from radioactive potassium in your body, like we mentioned earlier, and 12 times lower than a round-trip flight from Washington, D.C. to Los Angeles and back to Washington, D.C. And that's over a whole year, so this is really a very low amount of radiation. All right, so that was for 60 becquerel per water. Let's scale those numbers up to 1,200 becquerel per water, assuming that the Fukushima water would be in your well water. So this is drinking the straight Fukushima tritiated water that is coming right out of that pipe into the ocean. This is a 20 times higher level of contamination than we had previously. This would give you a 6 millirem dose in 1 year, 30 microsievert. So let's scale these numbers up for the comparison again. So this would now be 100 to 250 times lower than a full body CAT scan, 50 times lower than natural background radiation in a year, 2.5 times lower than your annual radiation dose from potassium in your body, and 1.5 times higher than the Washington, D.C. to LA to D.C. round trip. Again, this is over a year. That D.C., LA, D.C. round trip can take place in a day. So this is all to say that any fish in the vicinity of this Fukushima tritiated water release, first of all, will not see that concentration of water. Is going to spread out. And then second of all, even if they drink that water for like a whole year, they're getting such like a low amount of dose from it, and they're also expelling it from their bodies. And then it's a very convoluted way to try and say that it's going to harm people. So now, if there were radionuclides being released that were just like straight metallic radionuclides, that would be a problem. But this tritiated water is not. There are much bigger sources of risk in your life that you should be worried about. All right, now that we've talked about some of those dose examples, let's talk about what the government thinks is an acceptable amount of tritium to drink a year. So according to the United States Environmental Protection Agency, it is acceptable for a human in the US to get 4 millirem per year of radiation dose from tritiated water. And this is based on 20,000 picocuries per liter of tritiated water, or 740 becquerel per liter. So about half of the Fukushima release. Again, this is drinking this level of water for an entire year. In 1991, the EPA reevaluated these numbers and found that this level could be raised to 2,253 becquerel of tritium per liter per year to get 4 millirem per year. It's worth noting, though, that however, the EPA decided to keep the lower limit of 740 becquerel of tritium per liter. So that higher limit is above the tritium release concentration from Fukushima. And this is assuming that you were like putting your mouth up to the Fukushima tunnel and just drinking water for a whole year from that, which is like the worst case scenario. The reason I keep mentioning that is because it can't get any worse than putting your mouth up that tube of water coming straight out into the ocean. Okay, so what does 4 millirem per year of exposure really mean? I keep saying it's a low number, but let's quantify it. There's kind of two thoughts of how radiation affects the body. The one that the United States Nuclear Regulatory Commission accepts is the linear no threshold model. So what this basically means is that no amount of added radiation to your body is ever like completely risk-free. There's always some increased risk of developing cancer to any radiation level above background. The other thought is that there's some threshold, there's some lower threshold beneath which the radiation you get doesn't really affect anything. And I'm not sure which one I completely subscribe to. let's explain what the 4 millirem per year is supposed to do to you using the linear no threshold model, and then I'll explain some more about how I think about it. So according to the What is Nuclear website, which is a very good website, highly suggest you check it out. They have a calculator where you can enter in what kind of dose you're getting for what kind of amount of time, and then the calculator will tell you how much your lifetime risk of cancer has gone up by being exposed to that level of dose. We're going to assume this 4 millirem per year that we just talked about previously. Let's say you drink the Fukushima tritiated water for the rest of eternity. You'll understand why I say for the rest of eternity in a second here. Consistently being exposed to 4 millirem per year of tritiated water would mean that it would take about 2,500 years for your lifetime risk of cancer to go up by 1 in 100 chance. So for example, if your lifetime risk of cancer is 42%, which it actually is for humans, that's the average, to go from 42% to 43% would take 2,500 years. That's a very long time. And 1% is also a rather tiny increase. So this is where it's kind of like, okay, I can see what the linear no threshold is getting at is that no amount of radiation is good for you, but it's also kind of like de facto saying that there is some lower limit where you're never affected by radiation, because to take 2,500 years to increase your lifetime chance of cancer by 1%, just don't worry about it. Like, it's most likely really not going to happen that you're going to get cancer. And this is like, drinking this Fukushima tritiated water for 2,500 years. It's not like doing it for 1 year or 1 day, not even anywhere near those short levels of time frames, like for the rest of your life drinking this water, and you're not going to increase your risk of cancer. So there you go, guys. I just want to kind of go quickly over the Fukushima water stuff. I always like just trying to explain it my own way visually. Sometimes the articles, it can be easy to gloss over, see what it's really saying. So I wanted to give like some more background and some more context on some of the numbers that are being thrown out there. Of course, some people, a lot of people probably will be fine with if the article says it's safe, for like the IAEA, the International Atomic Energy Agency, says that the Fukushima water release is safe. But this is for, if you want to see these numbers quantified, see someone, break this down a little further. But yeah, thank you very much to the NRC's website. Lots of good info there. Check out the sources below for more, if you want to see even more about, about tritium, about the EPA standards for this stuff. And the What is Nuclear website, very good website. That linear no threshold calculator is fun to play with. Main takeaway from the Fukushima water is, don't worry about it. There are many more important things to worry about in your life than Fukushima water, like texting and driving. Don't do it. Thank you guys for watching. See you guys next time, and have a good day.